Elon Musk, the man behind various ambitious projects, has a plan to colonize the planet Mars. It would probably be the most ambitious plan of all. Although a couple of years ago this sounded impossible, by developing new technology and improving the old ones, this plan does not seem so unrealistic. One of these new technologies is the Raptor engine. This methane-powered powerhouse could single-handedly power Elon Musk's plan to reach Mars by 2024. Not to be confused with the Merlin engines that SpaceX uses on the Falcon 9 reusable rockets for its current launches. CEO Elon Musk announced that the engine reached 330 bar of chamber pressure without exploding. That's 31 bar higher than what the engine achieved back in February 2019. When it beat the previous record holder for an operational engine, Russia's RD-180. Teslarati noted that the engine beat the Soviet Union's RD-701 engine, which at 300 bar, previously held the public record for the highest combustion chamber pressure for an orbital-class rocket. Just to put you in perspective of how much more powerful the Raptor engine actually is than the Merlin engine only had 90 bar chamber pressure. So in this video, let's see how powerful the Raptor engine actually is and how it differs from other engines. Before starting this video, please consider the possibility of supporting us by subscribing to our channel and liking this video. If you like what we are doing, please share this video with some of your friends. Let's start this video now. There are tales of rocket technology being used thousands of years ago. For example, around 400 BC, Archytas, a Greek philosopher and mathematician, showed off a wooden pigeon that was suspended on wires. The pigeon was pushed around by escaping steam, according to NASA. Around 300 years after the pigeon experiment, the hero of Alexandria is said to have invented the aioli pile, also called Hero's engine, NASA added. The sphere-shaped device sat on top of a boiling pool of water. Gas from the steaming water went inside the sphere and escaped through the two L-shaped tubes on opposite sides. The thrust created by the escaping steam made the sphere rotate. Historians believe the Chinese developed the first real rockets around the 1st century AD. They were used for colorful displays during religious festivals, similar to modern fireworks. For the next few hundred years, rockets were mainly used as military weapons, including a version called the Congreve rocket, developed by the British military in the early 1800s. There are many interesting stories from ancient times where people have tried to make the first rockets, but we will be focusing on newer rockets, which are developed to take people and objects into space. Russian-born scientist and mathematician Konstantin Tsiolkovsky is often referred to as the father of astronautics and human spaceflight. His visionary ideas for the future of humanity in space were far ahead of his time. It is Tsiolkovsky who first determined that the escape velocity from the Earth into orbit was 8 kilometers per second, and that this could be achieved by using a multi-stage rocket fueled by liquid oxygen and liquid hydrogen. During his lifetime, he published over 500 works on space travel and related subjects, including science fiction novels. One of his most famous quotes tells us exactly how much he was ahead of his time and how much of an impact he actually had for humanity. Mankind will not forever remain on Earth, but in the pursuit of light in space will first timely emerge from the bounds of the atmosphere, and then advance until he has conquered the whole of circumsolar space. Engineers from the United States, such as Robert H. Goddard, and Germany, such as Hermann Oberth, would continue to establish the groundwork for creating rocket engines. After the Great Wars, rocket technology began to develop into its own field of research, and the space race was driven by the Cold War. The area of rocketry was about to enter a new era of technological advancement. These rockets were created with the goal of achieving escape velocity and breaking free from the Earth's gravity. However, ascending the Earth's gravity well proved to be a difficult undertaking. Then, on October 4th, 1957, the Sputnik rocket successfully defied gravity to deliver the Sputnik 1, the world's first artificial satellite. Sputnik was a substantially upgraded version of the Soviet Union's R-7 Smyorka intercontinental ballistic missile. Sputnik was the first satellite to demonstrate that it was feasible to travel up the Earth's gravity well. The rest is history, and the United States followed suit with its Saturn V rocket, which would carry the first humans to the moon. Other countries, including China, the European Space Agency, and India, began to join in with their own rocket designs as time went on. All of them were created with one goal in mind: to break free from the gravitational pull of the Earth. And now, it's time for us to talk about SpaceX, because they and their rockets will surely be remembered in history of rockets and space. SpaceX has set its sights on Mars and is redesigning rockets from the ground up to get there. Reaching Mars and returning would necessitate the development of a new spaceship propelled by a whole new rocket engine that has never been attempted before. SpaceX began work on Starship, formerly known as the Big Falcon rocket, a stainless steel, alloy-based spacecraft propelled by the Super Heavy booster stage. All that was left was to find a way to power all of these rockets. The initial decision made by SpaceX was to make the rockets reusable. SpaceX has always specialized on reusable rockets. They noticed the huge expenditures of one-time use rockets that NASA was employing for its spacebound missions and decided to do something about it. Why are we throwing away millions of dollars worth of equipment into the waters when we can create the technology to reuse it? Reusable rockets took SpaceX a few years and a lot of sweat and blood to create a viable alternative. Falcon 9 rockets have now become the industry standard for reusable rockets. Following the success of the Falcon 9 and its Merlin engines, SpaceX chose to follow a similar reuse concept. SpaceX was serious when they stated they'd reinvent rocket engine technology. The full flow stage combustion cycle was used to build Raptor. Raptor would be the first engine to employ this unusual gas cycle in orbit, and it has only previously been used in experimental rocket technology. This cycle employs both oxidizer-rich and fuel-rich preburners, to put it another way. Usually, it's one or the other. But the cycle enables both propellants to run freely through the turbines, hence the name. Because it has better control over the flow of the oxidizer and fuel, the Raptor engine can be more efficient than conventional rocket engines. Turbines that operate cooler and at lower pressure are among the additional advantages of employing a full flow stage combustion cycle. This is due to the improved mass flow, which leads to a longer engine life and more dependability, which is exactly what SpaceX was going for with the Starship engine. An engine with a longer life and greater dependability may be utilized numerous times without needing to be serviced. This will save expenses and downtime between launches substantially. The Raptor engine has a 25 flight rating at the moment. Considering what would happen if the Raptor had not been designed with reusability in mind, 25 separate rockets would be utilized for the same flights and then discarded. Another option for fueling the Raptor engine was to use cryogenic liquid methane. This design decision is, once again, unparalleled in the history of rocket engines. Most rocket engines use Rocket Propellant 1, or RP1, as their primary fuel. RP1 is simply a refined version of jet fuel. In fact, previous SpaceX engines, such as the Merlin engine on the Falcon 9 and the Kestrel engines, both used RP1. So when SpaceX announced that the Raptor would be powered by cryogenic liquid methane and liquid oxygen, it came as a shock to SpaceX fans. However, SpaceX was set on using methane as the primary fuel for the Raptor. The geological terrain and atmosphere of Mars are two of the major reasons SpaceX went through with this unconventional design decision. Because the Raptor was built particularly for the Starship and the Mars mission, when NASA's rover trips to Mars revealed that the atmosphere on Mars had a lot of CO2 in it and a lot of frozen water on the ground, SpaceX discovered that they could theoretically manufacture methane on Mars. If we could produce our own fuel on Mars, then the spaceship wouldn't have to haul fuel for the return journey. In situ resource utilization is the term for this. It is a technique to use the local resources to build a long-term infrastructure on an alien world. This is in keeping with SpaceX's goal for making Mars a self-sustainable colony that does not require assistance from Earth. In fact, the Saboteur process, which creates methane from carbon dioxide and water, also produces oxygen as a byproduct, which the colony will utilize. At the International Space Station, astronauts have previously utilized this tried-and-true method to create oxygen from water and remove carbon dioxide. Discussing the subject of water, some of you may ask why we can't use water and hydrogen to fuel the Raptor engines that will launch from Mars. To put it another way, While hydrogen is a more efficient fuel, it complicates the rocket engines and designs. Liquid hydrogen needs severe temperature control, it can leak quickly, and it's less dense, hence demands a bigger fuel tank. SpaceX wants their rocket to be simple, inexpensive, and dependable. The best part is no part, says Elon Musk, and the best process is no process. As a result, SpaceX chose a methane-powered engine over a hydrogen-powered engine. Methane produces a bright blue flame, which contrasts sharply with the yellow flame produced by RP-1 engines. This gives the Raptor engine a distinct appearance. In August of last year, at the SpaceX Okushika facility, SpaceX tested its Raptor engine on an SN5 Starship for the first time. In the hop test, a single Raptor engine lifted the SN5 500 feet before safely descending. Following the successful test, SpaceX conducted a number of further short hop experiments in 2020. Then, on December 9, 2020, everyone came to watch the first high-altitude test of the Raptor engine placed aboard the spaceship SN8. At Okushika, Texas, SN8 was equipped with 3 Raptor engines and soared to the sky. It rose successfully to its intended height of 10 kilometers, but on the way back to land, one of the Raptor engines failed to restart, and the SN9 overturned on landing, resulting in costly fireworks. The Raptor engine would fall again in high-altitude testing conducted at Boca Chica in February and March. But if we know anything about SpaceX, we know they don't shy away from failures. SN15 made history on May 6th when it successfully landed after a high-altitude test. It was a historic landing for human-powered spaceflight, and we should expect more exciting news from SpaceX in the months ahead as they develop the Raptor engine that will carry us to Mars. So that's it for this video. Do you think that Raptor engine will be able to take us to Mars? Write your opinion down in the comment section. We are really curious to know what you think about all this. And as always, thank you so much for watching. Don't forget to like this video and click on the subscribe button below, turn on the notifications, and get informed whenever we post our original content. Thanks again, and we are looking forward to seeing you.